Hi, Chris Good here. Let's go over the sample exam 3 output file in the SPSS work section. So number 1, use the data in Glastonbury Festival regression .save, that should be .sav, to determine whether change in hygiene is different across groups of people with different taste in music. Okay, Glastonbury. Let's go to Glastonbury. And DSUS for data Glastonbury. Here we are, Glastonbury Festival regression. Go ahead and open that. Great. Are people with different musical preference, that's musical affiliation, are different in their change. So change in music is change and different taste is music, so that seems pretty simple. Let's look at the go ahead and do this as a, you could do it either way. You could do it as a general linear model, or we could use the Anova table. Let's try it this way and make sure that we get it done both ways. So dependent variable is change in hygiene over the festival, and musical affiliation is our fixed factor. So it says do simple contrast. We can choose that from this menu. Remember, you got to hit the change button to change our contrast on the music factor from none to simple. Select simple, hit change, hit continue. A simple contrast will compare each group to a reference group, which is, in this case, it's the last coded group, which is no affiliation. Oh, and make sure you test for equivalence of variances. That's in the options folder. Homogeneity tests. All right. Go ahead and click on marginal means for music, just for fun, and we'll hit OK. SPSS tells you what it does: univariate analysis of variance. Here are groups: music affiliation, indie, metal, crusty, and no musical affiliation. Here's the Levine's test for equality of error variances, and we've got no significant difference among the error variances. That's good. Here's the meat and potatoes of the analysis. These are the tests of between subjects effects, and we can see here's our factor music. There's the sum of squares. Degrees of freedom, we had 4 groups, so 3 degrees of freedom between groups. Here's the mean square. Divide by this error variance and you'll get this F, which is significant. So looks like there is a significant difference. Let's check out the contrast to determine which one. So level 1 versus 4, that's significant. Level 2 versus 4, not significant. Level 3 versus 4, that's significant. So let's see, 1 versus 4, if we look at the means down here, that's indie kid was 1, the mean was 9.674. That means their hygiene was decreasing over the festival. So 1 versus 4. So indie kids are less hygienic. Their hygiene decreased more over the festival than those with no musical affiliation, and of course the crusty folks decreased even more. So that's the answer there, and we're done with number 1. Next, use the data in the file invisibility baseline to determine whether having an invisibility cloak, invisibility baseline, results in a difference in the number of mischievous acts committed, that's mischief 2, while controlling for the baseline mischief, that's mischief 1. Make sure baseline mischief is independent of cloak and that you calculate a measure of effect size. Let's do it. Well, I'll tell you what, let's check and make sure that mischief 1 is related to mischief 2. We can simultaneously check on our assumption of homogeneity of regression slopes if we look at a grouped scatter plot. Oh, that's not what I want. I'm sorry. I've chosen the wrong. There we go. Grouped scatter plot, not a grouped bar plot. Okay. So here's our covariate. That's on the x-axis. Here's our outcome variable, and we're going to group by invisibility cloak. All right, we're going to try to group by invisibility cloak. Oh, you know what? I think I've got the data file split for some reason. No, analyze all cases. Let's try it again. Grouped scatter plot. Set color by cloak. This was the baseline covariate. This is the dependent variable y-axis. And let's go. Are these related? Yes, they are. Look, positive relationship there. Let's get our separate regression lines. These are trending in pretty much the same direction, so I'm not worried about homogeneity of regression slopes. These are pretty similar. We could do a statistical analysis to confirm this, but we're just eyeballing it at this point. Let's make sure that baseline mischief is independent of cloak by running by running our first ANOVA here. So baseline is going to be the dependent variable with cloak as the fixed factor. If we get a significant effect here, that means that baseline mischief is not a good covariate because it's going to reduce the variability attributable to that independent variable. Okay, not significant, so let's proceed. We have made sure baseline mischief is independent of cloak. Finally, let's do the ANCOVA. So this is no longer the dependent variable. We're going to move it to the covariate box. The post-mischievous acts is going to be the dependent variable. We don't need to do any contrast because this is just 2 levels, but we do need to make sure we do estimate of effect size. And I don't need to worry about homogeneity tests at this point. Let's just go ahead and hit continue. And let's look at the analysis. It did a univariate. Here's the between subjects factor. And here is our covariate right here. And that once we control for that covariate, the mischief at baseline, we see that there's a significant effect of having a cloak. And here's our effect size. Partial eta squared is 0.128. So that's number 2. Hey, just out of curiosity, I wonder what it looked like without that covariate. You know I love to do lots of ANOVAs. Take the covariate out and see if we get the same significant effect. Ah, cool. Look. With so we did another ANOVA, but with no baseline covariate in here, and it's still significant, but the F gets smaller and the effect size gets a little tiny bit smaller. Why is that? Well, look at the error sums of squares here, 239. All right, there's more error in the denominator. There's actually a little more error in the numerator too without that covariate, so it shared a little bit, but not a significant amount of variance with the independent variable. I'm referring to the covariate, of course. Let's do this last one, shall we? Oh, this is tough. To determine whether stretching before playing Wii would reduce muscle and tendon strains after, that should be playing the game. Athletes and non-athletes were assigned to play Wii. Okay, so athletes or non-athletes is one variable. Assigned to play Wii or watch others, that's another. Stretching or not, that's 2. Pain scores are measured, that's the injury variable. And the data are in the file Wii.save. Let's find it. Wii. Alright, there it is. We're going to do our, run the appropriate analyses, interpret any significant main effects or interactions. Alright, because all of these are dichotomous variables, athlete or not, stretching or not, playing or not, and our dependent variable is continuous, we're not going to be able to do any contrasts or post hoc tests because they won't be implemented. They will, we can see the differences between these 2 levels by looking at means. Let's go ahead and click OK and see what we got. If we've got 3 factors, we're going to have a lot of Fs. So there's 1, 2, 3 main effects to look out for, 1, 2, 3 two-way interactions to look out for, plus a potential three-way interaction. Let's check it out. All right. So it ran Anova, gave the different levels of each of the 3 factors, and here's the giant source table with main effects of athlete or not, stretching or not, playing Wii or watching Wii, the athlete by stretch interaction here, the athlete by Wii interaction here, the stretch by Wii interaction here, and the 3-way interaction. So many significant effects. Main effect of athlete, main effect of stretching, main effect of playing Wii. And we don't see the means here, but if you go ahead and click on the descriptives, you can see that athletes report significantly less pain than do non-athletes. Stretchers report significantly less pain than do non-stretchers. And people playing Wii report significantly more pain than people who don't. But those main effects, you have to interpret them in terms of the 3-way interaction here. 2 of the 2-way interactions are significant. Athlete by Wii, stretch by Wii. But there's this 3-way interaction as well, which means that one of these 2-way interactions is different at different levels of the other factor, the 3rd factor. Really, the only way to see this is in the graphs. So I'm actually going to split this file by athlete. Let's see. So then I'm going to get separate graphs for athletes and non-athletes. And I'm going to graph. Actually, you know what? I'm going to use a line graph with error bars. And I'm going to set color by stretching. I'm going to try to set color by stretching. Playing Wii or watching Wii is going to go on the x-axis. I don't think I quite set the color. There we go. And we're going to measure a pain score. Alright. And we're going to display error bars that are, let's go ahead and say 2 standard errors. Alright. This is going to help us interpret this 3-way interaction. Alright. What would really help compare these two is if they had the same y-axis. So we have a graph for non-athletes and a graph for athletes. Let's see if we can't just go on the y-axis 0 to 10 for both of these. Change that one. Change that y-axis to 0 to 10. That's going to show the relationship, I think, a lot more clearly. Alright, so now we're comparing athletes on the bottom versus non-athletes on the top. Let's make this just a little bit bigger. So we could look at the marginal means and confidence intervals to check this out, but it looks like when folks are just watching Wii, right, stretching doesn't make a difference for athletes. Stretching doesn't make a difference for non-athletes either. That makes sense. If you're not playing Wii, if you're just watching it, then yeah, I hope that you're not reporting much pain. Folks who are playing Wii, if you're a non-athlete, you're going to report more pain generally, but stretching reduces that pain, and it looks to be significant just judging by the error bars. We'd have to check the marginal means just to be sure. Here, for athletes, if this difference is significant, it's not as great as this one is here. So for athletes, stretching may reduce pain, but it doesn't reduce it as much as for non-athletes, and that's the nature of the 3-way interaction. So there's an effect of stretching, right, that depends on whether you're playing Wii or not. That in athletes, that dependence is different than in non-athletes. So stretching decreases pain, but only when you're playing Wii for non-athletes, and stretching doesn't decrease pain as much when playing Wii if you are athletic. that actually kind of stands to reason. Okay, that's my interpretation of the main effects, the interactions, etc. Had to get these graphs from the chart builder to really fully interpret them, but that's it for the three-way analysis of variance. Thanks, we'll see you next time.